To make you understand 29th session on Miniconda environments better, let us understand some basic principles of Miniconda and why it is important. When you install multiple AI audio tools into a single shared Python folder, their separate dependencies start overwriting each other. Eventually, the conflict builds up and the entire setup breaks. To prevent that, we are going to build an isolated engine room. We will place everything from media processors to individual Python environments entirely on a dedicated D drive. Before we open the command line, we need three things: a Windows PC, a D drive with plenty of free storage, and administrator access to run system level commands. By keeping each tool quarantined in its own folder, we ensure that if a new text-to-speech model crashes, your translation and transcription models continue running safely. Step 1 is setting up your directory tree. Open your Windows command prompt as an administrator, so we have the permissions needed to create our root structure. We start by creating a master AI Studio folder on the D drive, branching into directories for FFmpeg, Miniconda 3, and an audio for inputs, outputs, and models. We also add a Git projects folder for cloning AI repositories via the command line. Now we need a tool to extract audio from video files. Download the essentials build of FFmpeg from gyan.dev, extracting its content into the empty FFmpeg folder. To let Windows know where FFmpeg lives, open Windows Search, type environment variables and click Edit. Find the path variable under System Variables, click Edit and add a new line pointing to the FFmpeg bin folder. This flowchart illustrates why we edit the path. When you type FFmpeg into any terminal, Windows checks the system path to find the exact executable file. Mapping it here means your Python scripts can trigger audio conversions from anywhere on the computer. Close the old command prompt and open a fresh one so the new path takes effect. Type git version and FFmpeg version. Seeing the numbers confirms the system recognizes both tools. With those commands returning successfully, we have established the underlying system needed to pull raw code from GitHub and manipulate media files. Instead of installing a single version of Python, we will install Miniconda. Run the Windows 64-bit installer, select Just Me, and point the destination path precisely to your AI Studio Miniconda 3 folder. On the Advanced Options screen, shown in this mockup, leave the Add Miniconda to Path checkbox empty. Checking this box can overwrite existing Windows paths and cause unpredictable terminal errors. Once installed, open the Anaconda prompt from Windows Search. Run two configuration commands using Conda config to force future package downloads and virtual environments to our D drive folders instead of the C drive. This diagram shows exactly how Conda protects our workspace. It generates these separate containers, allowing a transcription tool like Whisper to run on Python 3.10, while a different tool like IndicTTS run its own older dependencies securely next door. Using this container method guarantees that installing a brand new translation model will never accidentally overwrite the libraries, keeping our older voice generation tools alive. Now we test it. In the Anaconda prompt, use the Conda create command to build an environment named AudioBase using Python 3.10. Activate it, then install standard libraries like NumPy, PyDub, and Soundfile. Next, open Notepad and write a short script using the NumPy library. It calculates a 440 Hz sine wave over 2 seconds. Save the result to our output folder. Run that script through the active Conda environment. Check the output directory. Click on the new wave file and listen for the tone to prove the Python math translated into actual audio. We also need to verify our media processor. Write a quick FFmpeg command targeting that wave file to compress it into an MP3 format. If the second file appears, the conversion works. Warning tone. Before downloading any actual AI models, we have a storage problem. By default, Hugging Face downloads save to a hidden folder on your C drive. Within a week, those massive AI models will overflow your main drive and completely crash your operating system. To fix this, we use the Windows setx command to map the Hugging Face home, the hub cache and the transformers cache variables straight to the models folder we built on the D drive. Locking in these variables ensures that every 50 GB of voice model you download in the future is automatically routed away from your vital Windows files. To confirm the entire structure, we write one last Python script that actively queries the system for the location of our executables, the Conda environment name and the cache paths. Running that script prints out the results. Seeing the D drive path listed for Python, FFmpeg, Git and the Hugging Face cache proves our isolation strategy worked. Look at this checklist. We can confirm our goals. We have a dedicated studio folder, functional command line tools, isolated Miniconda environments, verified audio processing, and a protected primary hard drive. The next phase is getting this environment to talk to your hardware. We will install PyTorch and configure the CUDA toolkit so your Python scripts can tap directly into your graphic card for accelerated rendering. With the base engine room completely segmented from your operating system, you now have a stable, secure platform ready to host heavy industry-grade AI.